topic is image builds with disk image builder and Ansible. In this talk, we will explain the concept of disk image builder. We will see some demo with Ansible. Talk will be presented by Paul Belanger, who's the full-time contributor to OpenStack infrastructure, working in the Red Hat. Enjoy.
Thanks. So introduction. Hopefully you're here, you want to learn about image builds and particularly the way that we do it in OpenStack Infra and the tooling that we use. Before I start, I want to say thanks to Clint. He really primed the room for me here. He did a lot of good talk about Zool and CI in general. Didn't necessarily dive into the node pool side of things. This talk really relates to it. So while we did not coordinate beforehand, I could not ask for a better person to go in front of me. So who am I? So I'm a senior software developer at Red Hat. I am orged under the OpenStack infrastructure engineering team. What does that really mean? Not too much, because I don't actually do too much internal facing things. I have the luxury of working 100% upstream in the OpenStack project, specifically the project infrastructure team, where I am one of the, I think we're up to about 12 infra root people, the people that have the keys to all the systems. However, anybody in this room can actually manage all of our systems. All of our systems are open and public, managed via Garrett and so on and so forth. I'm part of the team that has to sometimes go and reboot or restart Garrett because it's running out of memory or something. So what we're going to be talking about, we're going to talk a little bit about OpenStack Infra in general, just to set you up on basically why we're choosing Disk Image Builder and Ansible. And we're going to talk a little bit about Node Pool, because Node Pool is the scheduler or the piece of software that we use to front end Disk Image Builder. Make sure I check the time here. So what is OpenStack infrastructure? Like I said, we're basically the team that manages all the systems behind the OpenStack project. It's done everything from the development, the testing, and the collaboration tools. So for example, I'm sure people know of JJB for Jenkins Job Builder. If you're using that, we maintain that as part of our code base and day-to-day because we use it extensively. Basically, the mandate is everything is open. Obviously not passwords or anything like that. Those are stored in a higher database. But any of our infrastructure is open with basically the purpose of having other people, other teams, other companies hopefully embrace that way of thinking and even start using our tooling. Like Clint was saying before, Zool and Node Pool are perfect use cases which grew organically out of the need to drive OpenStack as a project. And the super cool thing is that downstream contributors and downstream companies are now embracing those technologies. So more specifically how it relates, this really is OpenStack infrastructure. So you can kind of see we have our Garrett on the left, and that's the interface for the developers. These are our fleet of Git servers that we run because Garrett isn't powerful enough to do all of the load balancing of Git requests that we need on our whole right-hand side, which is our testing infrastructure. So Zool, we're not going to really talk about that today. We have the concept of a merger and a launcher. So these launch the jobs, these merge the code for the jobs. These are all of our public clouds. The part that we're going to talk about today is really this little box in here, which is Node Pool. Node Pool is the piece of software that launches the VM on the cloud. And because we deal with so many clouds, we deal with about 12, I think we're up to 12 clouds now, or 12 regions. We can't trust the images in the clouds because they're not uniform across all of our clouds. We started out that way, but then we started having to hack up our Puppet deployment scripts to say if Rackspace don't install systemd because that image already had systemd or something like that. So what is Node Pool? So Node Pool is a system for launching single unit tests on demand of image builds with cached data. And basically Node Pool started as a way for us to attach a dynamic slave into Jenkins using the Jenkins API, and then once Jenkins accepted that slave, we would then connect into that slave remotely via SSH to run our tests, and then same thing. When it was done, results come back, Node Pool would tear it down, or will tear it down, and start the process again. So basically there's three components of Node Pool today. There's the scheduler. I'm not really going to go into that. I just wanted to outline that's the loop that's actually going out and doing all the calculations of where demand lives. We have the concept of a launcher. This technically is still being designed now as part of our Zool v3 effort, but this will be massively scaled out. Currently, we really only support OpenStack clouds, but moving forward, first-class citizens, we're aiming for Google, Amazon, Kubernetes, like anything bare metal, all of that stuff is really falls under the new mission statement, I guess, of Zool and Node Pool. And finally is Node Pool Builder, and that's really what we're going to talk about today. And the reason I put Node Pool Builder in there, it's basically a very thin front end to Disk Image Builder, how we use it, but it gives us the scalability of distributing builds. So Node Pool gives us the ability to schedule our distributed builds across our infrastructure rather than having a single machine create all of our image, because there's not enough time in a day to build all of our images on one machine. So why? So why do we do this? So basically it's end-to-end ownership of an image build. This is important for us because images get deleted on clouds and there's no backup, and if we don't have that image, we can't test it and we can't reproduce it. Removes the dependency on other build systems. At the scale we deal with, we can't afford an outage of an upstream image being deleted or their build system down. Gets into immutable infrastructure. That's really what Disk Image Builder was created for, the concept of an immutable build. We use it to a degree, but other projects in OpenStack, which I'll reference quickly, really embrace Disk Image Builder in that aspect. Obviously security, yay, nay, maybe. But basically it's a potential tool to do a potential tool for single builds for both bare metal images, QCOW images for cloud images, and potentially container images. And like I said, it's reproducibility. So very quickly, Node Pool, some image data stats. We got 12 regions. We got 6 images that we built today. So 3 Ubuntu, 2 CentOS, a Fedora 25, and a Debian Jessie. These are the formats that we build. So QCOW2, VHDs are needed for rack space. And then we have raw images because sometimes clouds just need a raw image for their glance backend. And then basically two dedicated builders, Node Pool builders. This Node Pool builder concept is new for us. It's part of the Zool v3 effort. And it really allows us to scale this up to, we could have 6 image builders or 100 image builders or whatever it is. It truly is distributed building now. Okay, so getting into the heart of it, now that I've spent 9 minutes on that, what is Disk Image Builder? So Disk Image Builder is basically a collection of elements. And these elements at the heart of it are basically written in Bash. Now, love it or hate it, that's basically how we have it today. The concept of Disk Image Builder, though, is it's really a phased approach of building your image. So you have the concept of these phases here. So a root, an extra data, pre-install and install, post-install, block device, finalize, and clean up. Because we're dealing with CH roots, chroots, depending on the phase, it's something that happens outside of the image and something that happens inside the image. The majority of these stages happen inside the image. 2 that happen on the outside are obviously the root and the cleanup. And I'll explain a little bit more the way that I've chosen to kind of implement Ansible in the concept here. So some examples that are using Disk Image Builder that may not be using Ansible. So the Triple O project in OpenStack is OpenStack on OpenStack. That's the Triple O. It's meant to deploy OpenStack using OpenStack. Initially started by HP, Red Hat, and so on and so forth. Primarily now driven by Red Hat. This is the installer of choice for Red Hat. It is basically, again, all immutable infrastructure, image-based deployments, leverages Disk Image Builder. Bifrost is basically Ansible Playbook that does bare metal provisioning, uses the Ironic project in OpenStack, but the images that are used to boot the node the first time are generated by Disk Image Builder. They use Ansible to do the builds, but they don't have Ansible inside the container of the build. And then finally, us, node pool for projects. So the OpenStack infra, we have our own elements that define how an image looks for testing. More specifically, in our elements, we actually run Puppet inside of the image. This is for legacy reasons, because we are still a Puppet shop. By moving to something like Ansible, hopefully, we can remove some of those dirty dependencies that are needed for your configuration management on the inside of an image, and it starts living on the outside. So basically, getting into the heart of it, what's needed to actually do this? So basically, I've wrote a very simple patch, and I call it the simple playbook element. Can't get any more simple than this. And what it does is it's really meant to launch Ansible Playbook and define an inventory file to the CH root that has already been created in Disk Image Builder. And the reason for this is it allows us to use a single command to build the image and then overlay our configuration atop of it. Another way to do it would be to create the image, save it, and then uncompress it into a directory and then have Ansible do it. So that's totally valuable, a total reasonable way to do it, but the amount of data and the churn that we're doing, this makes a little bit more sense just to do it all at the first stage. So what does your playbook look like? So very simple. This is a very simple playbook that I have wrote to build a Docker image for Disk Image Builder. So I'm going to use Disk Image Builder to create me a container so I can run Disk Image Builder inside of it. Turtles all the way down, right? But the really cool thing about this is that if you're already an Ansible shop, or I might have skipped over it. Does anybody not know what Ansible is? Hopefully everybody's used it, seen it. Okay, great. The benefit of something like this approach, in my view, is you're not pinning your management of an image to the tooling that's building the image, which means I can take this same playbook and, in theory, use the SSH connection of it to manage my actual production running image, production running node pool service. Today, we can't necessarily do that in OpenStack infra because we have a different path that our Puppet takes when we say, if it's an image build, run this Puppet manifest, but don't start any of the services in the image because you can't really do that and Puppet gets a little bit crazy. So the whole idea is you have an existing playbook that you've written already for your production. Why not use that to create your immutable infrastructure at the same time? So yeah, so the connection root, like I was talking about, is Ansible connection CH root. Now, very funny, there isn't really much documentation on this, so it might be kind of a surprise to anybody that you can actually do this in Ansible, but yes, you can. Monty Taylor was gracious enough to tell me about this neat little hack, I guess if you want to call it a hack, but it's not a hack. It actually works fantastic.
So this is just instead of SSH?
Instead of SSH, yeah, it just puts it out to the existing mount that's been created by Disk Image Builder and does its thing, and then Ansible just stops working, and then Disk Image Builder does the cleanup, and so on and so forth. Yes?
Hey, Paul, can you make the slide a little bit bigger?
Oh, yes, I could, but I don't know how to do it. I should have blown that up just a little bit more. I'm sorry. When I post these online, I'll make them bigger. I know it doesn't help the stat. Okay, so basically, how do you run this command? Oh, I got 5 minutes. Man, I thought I'd have not enough to talk about. So basically, these are the syntax that we use. What we're setting up here, so these are div variables define the type of image that we want. So the top one is for a Ubuntu tarball for a trustee. The key piece of information is this, the type. So the top one represents a tarball we're creating. The second one represents a QCOW image. The third one also represents a QCOW image, but it's a different flavor. But it's the same playbook. That's the beautiful thing is it's the same playbook. So if your playbook in Ansible is written smart enough, it's a single point of entry, right? Node pool builder. So this is what it would look like in node pool. So to run this manually, this is the commands that you use. The cool thing about node pool builder is we can express it now in YAML format, a nice clean format, which OpenStack Infra loves. Everything we do is YAML based because it's perfect for code reviews, right? So these are basically environmental variables inside of a disk image builder that represent, Debian mirrors and so on. These elements are the elements that we want to install. So we want an Ubuntu minimal, which is a very basic Ubuntu image. A VM things, it does some stuff with the kernels. Simple init is basically a replacement that we run in OpenStack Infra for cloud init. And then some repos that we cache and so on and so forth. And then a fancy element that says some infra packages that we need that may not be in disk image builder. So from node pool's point of view, what does this look like? So we have a fancy command called div image list. This is yesterday. These are all the images that we've created. So you can see we have, by default, we keep 2 images in the cloud, which gives us a primary and a fallback. If we upload a bad image, we can immediately roll back and not have to do a rebuild. We got 3 going on here because we only delete the image once everything has been uploaded. And you can see on Debbie and Jesse, it's currently building. So, like I said, the cool thing is this is totally distributed across multi-machines for our image builds. It's backed by Zookeeper, yay or nay if you like Zookeeper. But these are the actual images, what they look like in the far end. So these are the images that we're uploading to the clouds. So you can see, I couldn't fit it all in because I would have had to scroll like 5 pages because we have massive amount of images. So just here we got, I don't even know what that is, 20 images across all these clouds. So these are rack space clouds and regions, OVH, OSIG. You'll see multiple OSIGs because it's the same cloud but different hardware profiles. Blue box, thanks Clint. And then InfraCloud, we have our own cloud and infrastructure now. Like the OpenStack infrastructure team is running a cloud on donated hardware. What else? So basically Docker. So you could do this for Docker. Really cool thing, Docker import. So you're just catting the tarball, sudo import, and then you're running your privileged container thing. Kind of issue with this, I haven't cracked the metadata issue because in a Docker file, you express your entry points and firewall rules and so on. I'm not really container-ish, but apparently there's a method to generate this JSON blob that represents this. I don't know how to do it yet. That's what so if anybody knows how to do it, point me to the person. Thank you. I'll come talk to you. And finally, I just wanted to say, isn't there a little bit of overlap with Ansible Container? Has anybody not heard of Ansible Container? So Ansible Container is an effort by the Ansible team to create kind of this concept. I've not really dove into it. I don't want to talk too much about it, but the main difference between that, from what I understand, is Ansible Container is leveraging atop of Docker build infrastructure, so they're not doing the raw image build, expecting an image to already be created and then overlaying their playbooks. Again, this approach that I'm discussing is end-to-end. We own everything and build it and so on and so forth. And I have, right on time. Out of questions, or out of time, questions. These obviously places and locations of everything for both Ansible and Disk Image Builder. Yes?
I like to put questions in first. So, my interest was actually in a slightly different part of this process, which you didn't cover. So, I was interested in the part where it says install. You say you're building the images end-to-end, but you're doing it in a true. So, say you're building a Fedora 25 image. Once it troops into the true, how does it put Fedora 25 into that true?
So Fedora, okay, so with Fedora we use, it's Disk Image Builder, and we have an element to use Yum Downloader, and we express what the minimum set of packages are. Okay. So when you went back and seen the minimal element here for Ubuntu, Disk Image Builder expresses what that minimal image is. Okay. Now, it's a static representation. In the process of trying to merge some of this stuff upstream, we had kind of a heated discussion of, well, Disk Image Builder wants to express this is the default because this is what the default is today. But in a container, you might not need Yum or you might not need any of this. So that's one of the, I don't want to say pain points, but that's one of the struggles as if you're going to go this route, you may have to create your own representation of a base Fedora that says, I want Yum and something else, and that's it.
So what you're doing is exactly matching up to Fedora to the middle. You're basically saying, we're going to grab these packages and install them into a true.
Right. Yes. So that's part of the things that we as an upstream project didn't really like. We didn't support Fedora until very recently. And the only reason we got to Fedora is because Ian in Australia basically said, we need something Fedora, and I'm just going to throw some code into this, and it magically works.
I mean, it's not just specific to Fedora. I meant to say with Ubuntu, you don't exactly match an upstream Ubuntu.
We try to, so Ubuntu's a little bit different. We use Deb Bootstrap, minimal build, right? Again, we express, we need, on the minimal image, we need Python 2 or Python 3 or something like that. But you're right. It's not exact duplication of upstream build methods. And I wouldn't say you don't want to do that. This is for you creating your images that you need for specific purposes. And our purpose is testing, right?
If I can just add quickly, I'm also at this there's also like an Ubuntu not minimal image, for instance, that just downloads the Ubuntu cloud image. Right. But most people who get into the game of Disk Image Builder, they want to start from as little as possible. Yeah. So like there's also like a RHEL one that just downloads RHEL and starts there.
Yeah.
And then you can also have the minimal ones, right, to pick and choose exactly what you want. Okay. So the important part is when you're writing elements, some parts of elements they can put things in from outside the truth, and some things run from inside the truth. Right. And that's how you get kind of a nice separation line. This is safe stuff. This is not safe stuff. Sure. Thank you.
So what I was gonna do while we were all talking is actually get this process going. After I made sure my actual builds worked. There we go. So basically this is what happens in the background. It's the boring stuff. These, you can see if you go to nbo1openstack.org, these are the actual log outputs. So after hours reading, you can go and see how we do this. Sadly, this isn't using Ansible, but the one that I had on my laptop running is using Ansible. So basically, when we get back to it, like, it's running Ansible now. It's kicked into Ansible, and now it's doing Ansible things via this chroot connection, which, like I said, the whole thing I was trying to express. 1 minute, last question. I'll stop talking. Okay, hopefully you found it informative, and yeah, thank you.
So you're now
Yes.
in a talk.
So I need a mini DVR.